Good evening, good afternoon, good morning. Okay, so as we are proceeding, fine. Okay, so as we are proceeding towards statistics, we had just started with the statistics. We did a lot of work into the statistics. So you can see in statistics, there are two categories. Can you tell me what are the two categories? Tell me two categories, please. Come into a live chat portal and interact with me and tell me what are two categories. What are two categories? Very good. Good, very good. Very good answers. So you are saying, ma'am, there are two categories, descriptive statistics. And the second one you are saying? Very good, good responses. So you are saying inferential statistics. When we talk about the descriptive statistics, there are two bifurcation. Can you tell me what are the two bifurcation? What are the two bifurcation? That one is central tendency and dispersion of data. Just tell me which part comes under central tendency. We had did it with NumPy and Pandas as well. Can you tell me what are the two? What are the parts coming under central tendency? Central tendency. That one is mean, median, mode. Okay. And what comes under dispersion of data? Dispersion of data. Very good responses. Good, thank you. So range, variance, standard deviation, percentile, and skewness. Basic, these are there. Now let's go ahead with the inferential statistics, where we need to infer the data. Thank you. Thank you for your responses. Let's go ahead with the inferential statistics, where we can infer the data. So here, when we talk about the inferential statistics here, we do have hypothesis testing. Under the hood of the hypothesis testing, we do have just like z-score, t-test, regression test, chi-square test, ANOVA test, ANOVA, MANOVA, MINCOVA. There are so many tests are there. So actual statisticians, those who are actually with the post of statistician, they work with a lot of data. ANOVA, MANOVA, MINCOVA. There are so many tests are associated into the inferential statistics. Okay, so people do all these things. So we are going to cover a few only because we are not requiring those that much. But yes, we should know what are the hypothesis testing, what are z-score, what are t-test, what are regression test, all these things here. Okay, because statistics itself is a wide field here. Fine. So Actually, let's understand how the inferential statistics work. So first of all, I was talking about few of the things yesterday also I had told you. Can you tell me what is this distribution? If I'm having such type of distribution, what this distribution says to you? What type of distribution it is? Can you tell me the name only I needed? What is this distribution? What is the name given to this distribution? Good responses, very good. So this one is the normal distribution. Normal distribution where we do have certain mean and certain standard deviation. If standard deviations are less, so my normal distribution will be coming in this way where the distribution of the data are very less, but if standard deviations are high, so my distributions are spread. The spread into the data, the range is very high. This is one case, normal distribution, or we can call it a bell-shaped curve. Already you are aware with. Now, can you tell me what is this types of distribution? Tell me, what are these types of distribution? What type of data we are having in such type of distribution? Okay, good answers, very good. So thank you for your responses. So these are skewed distribution, right tail distribution, left tail distribution. These types of distribution says whenever there is a skewness into the data are not normally spreaded, they are one-sided data. So here, these are the skew distribution where mean is greater than median in case of right side distribution, and here mean is less than median in left side tail distribution here. Thank you for responses. I also told you, like when we talk about the normal distribution, there is a 3 sigma rule or empirical rule, which says that 68% of the data lies up to 1 standard deviation, if this is the mean. So lies up to 1 standard deviation. And 95% of the data lies up to 2 standard deviation away from mean. 2 standard deviation, mean plus 2 standard deviation, mean minus 2 standard deviation, and 95% data lies. And 99.7% of the data lies between mean plus 3 standard deviation and mean minus 3 standard deviation. So up to here, the data are lying. Now there is one question coming here that what about the 0.3% data, where it goes actually? So that is here. These data are far apart from 3 standard deviation, and these data are basically outliers, and outliers are basically far away from 3 standard deviation. Any data which is far away from 3 standard deviation from the mean value, this is the mean value, and any data which is far away from 3 standard deviation, that is an outlier. Outliers are also known as the abnormal data. And these data which lies under up to 99.7, so these are normal distribution. These data are normal distribution. Okay. So just to detect the data, can you give me the name of the data visualization graph which I can use? Can you tell me which data visualization graph I can use just to detect just to detect outliers here. So thank you for responses, those who are responding continuously. So here we do have a box plot. Good. Box plot is one of the methods through which we can detect whether we are having outliers or not. any data which are lying here or any data which are lying here, these are basically outliers. So any data, these are up to 3 standard deviation. These are up to 3 standard deviation. Any data which are lying above or below, these are 3 standard deviation. They are outliers basically. Can you tell me what does this value belongs? What is the indication of this point? This point where my pointer is going on. Tell me. Good. So you are saying this one is minimum. Can you tell me what does this point belong? This point where my pointer is moving. This point you are saying maximum. Tell me what does this point belong? This point. Tell me the name. What does this point belongs to? What does this point belongs to? We can call it a Q1 also. How many percentile it is? So this one is 25th percentile. And how much this percentile is this one? So here, this one is median, 50th percentile. And what is the value lying here? Here. This one is thank you, Q3. So this one is 75th percentile, 75th percentile. So these 5 information box plot is giving to me. What is this value? Can you tell me? Think it. Try to remember the name. I'd given certain name. What is this? The difference between Q3 minus Q1. What is the name we can give it? You can just give a short form only, that's all. Oh, wow. So good answers. IQR, thank you. So that one is IQR into quartile. So this is all information we are trapping out with a box plot. So this one is a graph. I can take it just to check it out, the values of the outliers. Second thing, I can use one technical method to detect the outlier. That one is a z-score. Z-score is x minus mean divided by standard deviation. Okay, this one is a basic form of z-score here. It means here it's statistically I can use that, or mathematically or technically I can use z-score value x minus mean divided by standard deviation. Okay, fine. So let's take certain examples here for the z-score. Actually, during the statistics, we need to make the conceptual understanding of these statistics here. Okay. So here, let's understand z-score now. Students, you can find out all this PPT in Notes and Resources repository. Once you navigate Notes and Resources repository, they are into the end section, bottom last section. You will be getting certain link. Inside those links, these PPTs are there. You can just check it out. Okay. Okay. So what is a z-score? Z-score is a numerical segment used in statistics of a value to find out the relationship to the mean of a group of values that is measured in terms of standard deviations from the mean. So I'm taking few very basic examples of z-score just to understand how the z-scores we are using. These are certain definitions that we wrote here. This one is a basic formula, x minus mean divided by standard deviation. So this particular sign, this particular sign denoted as a mean. And this particular sign, this one is a standard deviation. Okay, so let me take very simple example here. Fine here. Suppose this is there. What is this? This is mean value. Basically, now there is one of the problem statements. Suppose I am having certain data related with length of wings of turtles. Means here turtles, na tortoise, baby tortoise, turtles. So their wing lengths are there. Okay. 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 So basically, na here these are the length like 2 centimeter, 2 centimeter, 3 centimeter, 2 centimeter, 5, 1, 6. Now here I want to calculate what is the z-score value. It means I want to understand how much is the dispersion of data or how much these data points. These all are data points. I will call it a data points. So how much these data points are far away from the mean. So I can calculate the z-score. With the help of z-score, I can understand that how far away these data points are from the mean value. Okay. Okay. So what I will do, if I want to calculate the z-score, first I need this formula. X data points minus mean. This is the mean divided by standard deviation. Standard deviation, or you can call this one as the mean. X minus mean. X means data points. Data points means these are the data points. So X minus mean divided by standard deviation. I need to calculate the mean value. So what is the mean value? It is pre-calculated. Mu is 3. So I will be taking mean as a 3. So mean value is basically 3. It is calculated. One has added the entire data divided by total number of counts of this data, like 1, 2, 3, 4, 5, 6, 7. So adding all this data divided by 7 will calculate the mean value. This one is the standard deviation calculated. Standard deviation is 1.69 here. So standard deviation is calculated on the basis here x minus mean divided by n, making the square of it in this way. So this standard deviation is calculated 1.69. So basically 1.69. So here it means mean value is 3 and standard deviation is 1.69. So if we want to calculate the z-score, so x minus mean divided by standard deviation. So any data point, if I'm having x minus 3 divided by 1.69, that I need to take. So now let's calculate what is the z-score value of this 2. Hai na? 2. What is the z-score value of this 2? So this one is a data point. So if I want to calculate the z-score, simply what I do, here I would be keeping the value of this 2 as 2 minus 3 divided by 1.69. So if I calculate, I will be getting the z-score value of this particular data point. Same here. Here, if I calculate to 3 minus 3 will be there, it will be 0. Now, for this one, again, same value will be kept. What about this 5? Suppose 5 is there. I want to calculate the z-score value. So here I'll just write 5 minus mean divided by standard deviation. And for 6, I can just write 6 minus 3 divided by 1.69. So we can calculate all these things. Okay. So once we are calculating all these things, we are getting the z-score value. So, just wait here. Wait. This one. So these are all calculated value. You can see here. These are calculated value. This one. So you can see here. Like 2 is there, no? 2 minus 3 divided by 1.69. This one, 2 minus 3 divided by 1.69. That is equivalent minus, if you are calculating it, that is giving you a value minus 0.59. This is the z-score value. Same minus 0.59 will be the value coming here at 2 also. One can calculate the value here. It will be 0 because 3 minus 3 will be 0. For 2, it is same. For 5, 5 minus 3 divided by 1.69. And for 6, 6 minus 3 divided by 1.69, same. So what is the z-score value? One is getting 1.77. Now, what to understand with these values? These values, though it is calculated by using all the z-score formula, but what should I understand? How can I interpret the result? What should I understand? What is happening actually? So for this now, we should understand here. See, basically z-score is calculated to understand how well the data point is standard deviated above the mean or below the mean. Okay. So here now, what I'll do, suppose you say minus 0.59 is there. Let's say this value is there. And what is the data point? 2. 2 is the data point and this one is the standard deviation. Now, what should I understand here? Suppose let's say the value is coming here minus. Minus means if this is the mean value is 3. Whatever is the mean value. So here, minus goes this side, minus this side, minus, and plus values goes this side, positive sides here. So here it is saying minus 0.59. So here it is saying the data point 2, let's say it is saying the minus 0.59. So this is minus 1. So minus 0.59. So 0.59 will be lying here, 0.59. So here it means my value of 2 data point, this one, this is lying here. What does it mean? The data point 2 is 0.59. The data point 2 is 0.59 standard deviated below the mean. The data point 2 is 0.59 standard deviated below the mean. It is below the mean. It means the 0.2 is standard deviated, 0.59 standard deviated below the mean. Whenever minus sign is coming, it means that one is below the mean. If plus sign is coming, positive sign is coming, that is above the mean, Now, if I take this value, 1.77, so how should I understand? 1.77. So it is positive. So I can take a value such as 1, 2, 3. So 1.77 means somewhere the values are lying here 1.5. Let's take it, and 1.7. Let's see here. At this point, my 6th data point is lying here. What should I understand here? I can say the data point 6 is 1.77 standard deviated above the mean. The data point 6 is 1.77 standard deviated above the mean. Got the point? It means how much the data point is standard deviated above the mean or below the mean. So it means these number of wings, 6 centimeters, is above the mean. How much? 1.77 standard deviated above the mean. In this way, I need to interpret these values here. Okay. So this is one case I had taken. Just as an understanding, I want to develop that how we need to interpret this data. Okay. Now, let's take another case. Be careful in this case. Let's say here, before applying to law school in the United States, students need to take an exam called LSAT. Law set examinations will be there. And second, before applying to medical schools, student needs to take MCAT examination. So either it is a LSAT or it is a MCAT. Now, when we talk about the LSAT, what is the mean value? 151 is the mean value. And standard deviation is 10. So it means in this case, 151 is the mean value, and standard deviation means plus minus 10. So it means 161 means mean plus 10, mean minus 10. So 141. So here marks are lying between 141 to 161 in LSAT examination. And what is happening in MCAT? So mean value is 25.1 and standard deviation is plus minus 6.4. So plus 6.4 this side, minus 6.4 this side. Okay. Now let's see. There is a student, Juan. He took both examination. He gave law set and medical cat. He scored 172 marks in LSAT and 37 on MCAT. In which exam did he do relatively better? If I want to understand, so I can find out the Z-score and can understand where he is doing better. So for this, we need to calculate the Z-score. So what I will do here, to calculate the Z-score, I will be using LSAT examination. So here, wait. So first of all, one is calculating the LSAT examination here. For LSAT examination, how much student has achieved 172? So this one is the data point. So 172 minus mean. Mean of the LSAT examination is 151 divided by standard deviation, which is a 10. So one can calculate the Z-score value, and calculated Z-score value is 2.1 in this particular law cat. Now come to medical cat examination. And here, if we try to understand how many marks, 172. So 172 minus mu minus 25.1 divided by 6.4. So we are getting how much? 1.86. We are getting 1.86. So 2.1 is the z-score value in LSAT examination. 1.86 is calculated z-score in MCAT examination. Okay. For this now, so two values we are getting, 2.1 and 1.86. Now let's try to understand where he is doing better. That student is doing better in MCAT or LSAT, law examination or medical examination. So 2.1 is coming from LawSat and 1.86 is the z-score value coming from MCAT, medical and law. Now, if I try to understand this one, 2.1 in LSAT, so here, if I started making here, wait, this one, no? What is the mean? Mean value is 151. So mean value is 151. It could be any mean. Okay. Now, how much is the standard deviation? 2.1. It is positive. So come towards the positive side. So here 1, 2, 2, 2.1 here. Let's see here. So here. So basically, how much? Just wait here. How much marks student is gaining in LawSat? 172. So it means we can say, and this one is related with the LawSat, law examination. So we can say the student achieved 172 marks. 172 marks, that is 2.1 standard deviated above the mean. 2.1 standard deviated above the mean. So it means 2.1 standard deviation above the mean, the student is achieving 172 marks. How we can understand this particular medical examinations here? So we can say here, like here mean value is 25.1 and 1.86 is the value coming here. So 1, 2. So 1.86, 1.5, 1.86 here. Here. It is also positive. So 1.86 and what is the marks here? 37. So medical examination, MCAT examination. So the student achieved 37 marks, that is 1.86 standard deviated above the mean. In medical examination, 1.86 standard deviated above the mean, and in law examination, 2.1 standard deviated above the mean. Student, can you tell me in which examination he is doing better, law or medical? In law, he is 2.1 standard deviated above the mean. In medical, 1.86 standard deviated above the mean. So you have to tell me that in which exam that student is doing better, in law examination or medical CAT. Think it, think it, think it. Everybody should give the answer. Only few are giving answer. You should tell me, now understand. I need more answers, please. Very good. Those who are responding, no. Those who are responding LSAT examination, they are correct. Those who are responding LSAT examination, they are correct because the student marks is 2.1 far away from the mean. So it means they are doing very better, very good. But in medical examination, it is only 1.86 above the mean. So it means marks are not far away from the mean. So the students who had achieved 2.1 standard deviation far away from the mean. 2.1 means 2.1 far away from the mean value. So it means the student is above from the mean at very far away values. In medical only 1.86, but here in 2.1. You got it? So LSAT is the better. So student did well in law examination. Don't think that 1.86 is near to mean value. That is wrong. No, you have to think that Any standard deviation which is far away from the mean, so it means student is achieving more marks. Okay, so LSAT. Okay, so in this way you need to understand these values. Okay, so interpretation in this way we can give it. Okay, so these are all like here LSAT examination he is doing better. So the point is here that in this way we need to understand the data. Okay, this one are here, just calculation. I'm doing it here, basic calculation. Okay, let's go. So basically, now you should know here, like when we talk about the G score value. So remember, any data which is any data which is far away 3 standard deviation, so they are outliers or abnormal data. Rest of the data which are lying here up to 3 standard deviation, they are normal distribution, normal data. Their data are symmetrical, and their mean, median, mode values are 0, standard deviation values are 1. So that one is symmetrical, but any data which is far away, that one is abnormal data or abnormal data here. Yes, if the data are moving into the minus, so it should be closer to mean, correct? Okay, now there is one of the theorems, central limit theorem, CLT. So basically central limit theorem says, let's understand what this theorem says actually. Suppose here I am having any data here I'm having. Okay, let's take, suppose I'm taking that in Europe, what is the data scientist salary? Suppose here I'm having 10 lakh people salary I'm having. So these are the data points. These are the data scientist salaries I'm having. 10 lakh people data scientist salaries I'm having. Now, if I want to understand what is the average salary, I want to understand what is the average rate going on. So for that, I can just take this entire data. I can call it as the population. Entire data, I can call it a population. But what I can do just to find out average, I can just take the subset of it and can find out the average sal. I can take this subset and I can find out the average sal. Or I can take this subset and I can find out average sal. So basically, now, central limit theorem says that any data which is far away, any data which is whenever we want to find out average and we are selecting certain subset sample from the entire population, so the average value which we are getting, this average value is similar to the another subset average values. So average values which we are calculating from 3 different subset, they are similar. So it means I can say the average data scientist salaries are almost similar. Okay, to similar here. Just wait. So here now, so this one is similar. It means the average value which we are getting, that one is a similar. So different subset average values will be identical or similar. Okay, so this one is a CLT, central limit theorem. Rohit, Paul here. Your answer will be just with 1.37 in this case. 1.37 minus 1.37 in this particular case you're asking. Is it okay? Getting minus 1.37 for the question which you are asking. That would be the answer in a particular case. Okay. Okay, so there will be. Okay, so this is a case of central limit theorem. Now let's go ahead with a very important hypothesis testing and let's understand what is a hypothesis testing. In case of hypothesis testing, basically now, which people do this hypothesis testing in statistics? The people who are related with the research, they are doing certain research work on certain new theme. There we do the hypothesis testing. So this is not only related with the statistics. In a simple way, I'll tell, like the people who are into the PhDs or the people who are into the masters and they need to submit their final reports. So certain projects are assigned there at that time. So there we do hypothesis testing and basically into the market research also, or PhD people, every PhD person needs to do the hypothesis testing. Or in market research also, we need to do the hypothesis testing. Now, this is very important case here, hypothesis testing. So let's understand what is the hypothesis testing, how we do the hypothesis testing. Here, you are not going to do any hypothesis testing, but because when we read the statistics, so there is a concept of hypothesis testing and one needs to understand what is the hypothesis testing. Okay, where we need to prove any particular statement with the help of evidences. So that one is basically hypothesis testing. So hypothesis is an objective method of making decisions or inferences from sample data, evidence. So it means whenever I want to prove my statement, I need the evidences. And evidences are based on my collected data. Okay. So I'm going to take a simple statement here just to understand how we do the hypothesis testing. Okay. So first of all, whenever we work on hypothesis testing, okay. So here we need to make certain statements to which we are doing a research work. To make the statements, we need to think that what research work we are going to do and what is the objective of the research. Now, suppose here, I'm taking an example. Suppose I'm thinking I want to open certain pharmaceutical company, pharma company, where I would be developing their certain diabetic related medicine. Let's take a very simple example. I'm taking hypothetical. I'm just making it. So diabetic related diabetes. So first of all, actually, before making any medicine, I need to prove certain data that where I can have certain evidences that let's do certain exploration that what is the percentage of the people who are suffering from diabetes. Means generic idea, a very general, very hypothetical statement I'm talking about, just to understand that how hypothesis testing is helping us. Okay, this is not targeted to anyone, nothing, only hypothetical statement I am making. So I want to understand, like, okay, before it, let me do certain market research or general research where I can understand what is the percentage of people are there, just they are suffering from any diabetic, like from the starting of diabetes are they are having the high diabetic problems in this way. So here now, first of all, I need to understand the percentage. Percentage means nearby how many percentage of the people are suffering with diabetes. So here I'm making a statement here. So whenever we do hypothesis testing here, we need to make two statements. One is null hypothesis. We call it a H0. This one is a null hypothesis. And the another statement I need to make HA or H1, which is also known as alternative hypothesis. Alternative hypothesis. Okay. Okay. So now, in null hypothesis, I need to build up a statement just to understand. I can say, like, just wait here. Like, at the age of 60 and above, people start now. I'm giving a percentage. I'm giving a percentage here. So I can say about 60 and above. First statement here I'm making. More than 50%, means at the age of 60 or above, more than 50% people suffers from diabetes. So this is the general thinking I'm making. So I want to prove that, is it really that above 60 people, 50% of the people are suffering from diabetes problem? Any kind of, it could be a diabetic problem. Okay, this is one of the statement. So this statement I'm favoring actually, because I think it actually happens. But see, whenever we do market research or we are doing a hypothesis testing, we cannot rely on the statement which we think. We need to prove the alternative also, because everything which we are thinking is not true. We have to come up with evidence now. So I need to build up another statement here. So I'm just reversing this statement. The statement which I gave, I'm reversing it. At the age of 60 and above, less than, I'm reversing, 50% people suffers diabetes. So I'm just reversing the statement entirely. I'm saying, no, it is not true that you are thinking that 50% people are suffering from diabetes above 60 or above age. No, it is less people, very less people. It is below 50%. So two statements are there. One is null hypothesis, another one is an alternative hypothesis. So once I fix the statement, now I start making just to find out the evidences. For this evidences, I need to prepare the questionnaires. And those questionnaires I would start sending manually also, or with the help of Google Forms, I can send them. To whom I'm sending? I had just find out with certain agencies like certain people who are above 60 ages. So with a request or nearby neighborhood or park also, or clubs also, clubhouses. So I started approaching the people, like where the people are above 60, they are into the retired stages. So I started approaching these people. So I created a Google Forms also. I created a on paper questionnaires also. And all those questionnaires are built up in a way where just I'm not targeting any personal things, but generic things I'm targeting. And from there, I'm asking also whether they are at what is the age bar they are having, what is the age, approx age they are having, and whether they are suffering from any kind of diseases after 60 above, and what type of kind of diseases they are suffering. That type of questionnaire, certain, I say 10 to 12 questions or 15 questions I had prepared. Nearby from there, I'm getting the idea that they are suffering from diabetes or they are having a pain in body. They are taking certain medicines also, or maybe they are having certain other disease also, because that can happen. So just an idea taking only I'm going to do. With the help of 15, 20 questions I'll build up and request anybody on the personal basis if they want to fill up the questionnaire, that is up to them. So I'd collected certain data. So nearby, suppose I say I approached 5,000 people who are into the age of about 60. Anyhow, I traced them, like I'm saying, I just approached certain parks, I'd approach clubhouses, I'd approach other places where I can find out about 60 people, or with certain databases also, I can find it out. So with the help of emails also, we are asking them to fill up the form. If they are willing, that is up to the choice of them. So nearby, I am able to collect 5,000 people data who are above 60, and they just fill up the data and just put all the details, whatever is asked into the questions there. Now it's okay. Now I have to analyze this data, 5,000 people data. So what should I understand with this data? I took this data and I put it into the software. Okay. So inside the software, I start evaluating the data. Now there are certain software. If I tell you, like maybe I don't know if you had heard about IBM SPSS software is there. Generally, researchers use that software. IBM SPSS software, usually used for the research work. Nowadays, we are having a lot of libraries in Python also. There also we can put the data and we can work on it. Okay. So here now, when we talk about this 5,000 data rows I had collected, which means I had collected 5,000 people data with their self-desires, willing. So I put them into the Python software and start evaluating. Now in Python software, I'm having a lot of libraries which I can use. So see, how can I understand what they are saying? Here comes certain test. So here, actual statistician do the work. They start doing certain tests. They do t-test, they do regression test, they do z-test, they do ANOVA test, MANOVA test, MANCOVA test, and there are lineup tests are there. But what should I be doing with the test actually? How can I understand this test? Actually, we need to interpret the test result. Directly, I cannot understand what this is saying. So here I need to understand what these tests are giving. So basically this test gives us the p-value. Now listen carefully, that is very important. This test gives us the p-value. What is this p-value? P-value is the probability value. If this p-value is greater than 0.05, if this p-value is greater than 0.05, so in that case, I will say, now see, you think it, When I had collected a 5,000 people data and start evaluating their tests with the help of all these tests, so I had finded out the p-value. In p-value, I have to check whether the values I'm getting, p-value is greater than 0.05. So here, when I'm getting here 0.05, so here, 0.05, so here I'm getting it. So here, I need to understand what is this data saying, 0.05. So p-value is greater than 0.05. So I need to understand that null hypothesis is accepted. And alternative hypothesis is rejected. Okay. Null hypothesis is accepted and this one is rejected. What does it mean? If the p-value is greater than, I had find out a result that p-value is greater than 0.05. So null hypothesis is accepted. It means at the age of 60 and above, more than 50% of the people are suffering with the diabetes. I came to this conclusion with the p-value greater than 0.05. So I say more than 50% of the people are suffering with diabetes with above 60 age. And this is true with the help of evidences. And I'll say alternative is rejected. So this statement is not true. Now we think it out a reverse situation. Suppose after evaluating this 5,000 rows, I get different results with the help of this t-test and other test here. So let's take, I'm getting a different result such as p-value is less than 0.05. Suppose I'm getting a result that is less than 0.05. So that one is, this one is 0.05. Okay. This means that null hypothesis is rejected. And alternative is accepted. It is a reverse statement. It is reverse statement here. Okay. So this is there. So this all happens with the help of test only. Either it is accepted or rejected. So if the p-value is less than 0.05, so here we can say null hypothesis is rejected. It means at the age of 60 and above, more than 50% people are not suffering with diabetes. Though this is true, at the age of 60 and above, less than 50 people are suffering. 50% of the people are suffering the diabetes. So the point is here, once we do the test here, we need to understand the p-value. If the p-value is greater than 0.05, so in this particular case, null hypothesis is accepted. So whatever statement related with the null hypothesis, that will start working, that is true. And alternative hypothesis is rejected. So the statement associated with the alternative hypothesis is rejected. Second, if this is reverse, if the p-value is less than 0.05, so in this particular case, we will say null hypothesis is rejected and alternative hypothesis is accepted. Okay, so whatever statements associated with the null hypothesis is approved only when p-value is greater than 0.05, right? So if the values are greater than 0.05, so null hypothesis accepted and it is rejected. This is rejected, HA. And if it is reverse, so null hypothesis is rejected and HA is accepted here. We will be getting all these statements with the help of p-value. Okay. So this one is there. So basically we can say here that if I say here our value 0.05 is lying, and here just wait here. Just wait here. So this one is basically hypothesis testing, where we need to understand that which part to go, whether we need to go to null hypothesis or alternative hypothesis. Okay. So this hypothesis we need to understand how this is working, null hypothesis and alternative hypothesis. So here now, just wait, let me tell you. Just wait, just wait here. So when we talk about the p-value here, so basically a p-value is the probability of rejecting a null hypothesis when the hypothesis is proven true. Okay, so p-value should be greater than 0.05, then only my null hypothesis is true. Alternative is false. Alternative is rejected. Null hypothesis is accepted here. So here now, when we talk about 0.05, so 0.05 is basically a significance level. 0.05 is significance level. So if we say 1 minus 0.05, that becomes 0.95. So now 0.95 is a confidence level. So basically, when we say that my null hypothesis is accepted, so it means confidence level is 95%. So the values which are coming into the 95%, so this region is accepted region. This region is accepted region. It means 95% of the people are accepting the null hypothesis. And if my values are less than 0.05, so that comes into the rejected region. So whenever my null hypothesis is accepted, so in that case, 95% of the people are accepting the statements of null hypothesis. That comes into the accepted region. And here, 0.05 people are there, which is just approving alternative hypothesis. So that comes into the rejected region. Okay. So just to prove the null hypothesis, the values of null p-value should be greater than 0.05. That should be greater than 0.05. Okay. So that one is a null hypothesis. So that one we call it a confidence level. 95% is a confidence level, just to prove our null hypothesis here. Okay. So what we can do, how we can understand it in detail, more detail here. For that, there is one of the t-test here. So suppose here, there are certain tests, and these tests are inside scipy.stats. We are having these tests. So when we talk about the t-test here, so let's say here in t-test, mean values are given here. Okay. So whenever I want to find out the mean value and I want to approve whether in t-test, suppose here I'm taking a height and weight. Let's check it out. Just suppose I'm having two variable, height and weight. So in height and weight now, what we can do, suppose I want to understand, I'm having 50 rows in height and 50 rows in weight. Now I want to understand whether the height and weight are having the same mean. So for that, there is a t-test. Just to calculate the mean value, there is a t-test here. So there are certain type of t-test. Okay, t-test, independent, certain tests are there. So I can use those tests from scipy.stats. And inside the scipy.stats, I can pass on the values of height and mean. Means I can pass on the variable of height and weight. So automatically what these variable will do, here I'm just passing the data frame in which data frame I'm going to load any data set. So their height and weight variable, I'm going to pass it. So what this t-test is going to do, basically t-test is going to prove whether I am having their mean identical or not. Okay. So by default in t-test, the null hypothesis says the mean, it says the two mean values are identical. This is the default null hypothesis inside scipy.stat t-test. The two mean values are identical. It means this value and this values are identical. The mean of height is identical to the mean of weight. And alternative hypothesis is the two mean values are not identical. The two mean values are not identical. So this one is the statement. Now, when I will be passing on the DF height and the DF weight, so internally this t-test will be calculating what is the mean for this, what is the mean for this. Okay, so it will be starting finding out the mean values here. So suppose here 5.5 it is saying and 5.5 it is saying. So if 5.5 I am having as a mean value, so it means they are identical. Or I can say suppose here I am getting a value of 5.8. Let's say 5.8 here, 5.8 here and 5.5 here. So the point is here, I will say 5.5 and 5.8. So it means still the two mean values are identical. Okay. So here, please watch out the video. For this, you need to understand, you need to rewatch the video, please. Though the topic is complex because you are going to be a data scientist. So here, you need to rewatch the video because the topics slowly they will be growing up. You need to please rewatch the video 1 or 2 times more, then only you can understand these points. Now here, when I'm getting suppose 5.5 and 5.8 as the value, okay. So here what will happen in this case, one can say that yes, their mean values are identical, they are nearby. So if this happens, so I need to check it out, what is the p-value? If the p-value, I'm finding it out, that one is greater than 0.05. So I will say the two mean values are identical. So it means here we can say, yes, null hypothesis is accepted. The two mean values are identical and alternative is rejected. It means it is proven the two means values are identical. So let's see how to do the t-test. Okay, so just you need to understand here. This one is one of the things I've shown you how to work with the z-score. If I want to find out the z-score of any value, so simply I can write here from scipy.stat import z-score, and I can just give any value and find out the z-score. So here these values which are coming, these are the z-score values of these data. So scipy.stat is a very wonderful library where we can do all the inferential statistics. Let's come here and let's understand how we can apply with the t-test here with the given values here. Let's take here one of the CSV file here. Suppose here I'm loading one of the file, brain size.csv. So here I'm taking a random file here. We can take any file. So here, when I am checking out this file, so you can see there are certain columns such as ID, gender. You can see certain, these are medical values are there, just such as FSIQ, VIQ, PIQ. These are certain medical value. And then comes to the weight, height, and MRI count. These all value related inside these columns, they are coming from the brain size.csv. So actually one is counting the brain MRI count. So, and this FSIQ, VIQ, I can take any column randomly and I can find out the t-test because all these columns are numerical values. So height and weights are also given. So what I'll do, if I want to have the t-test here, so here, if I want to have the t-test here, so I can take any of the column FSIQ, VIQ, PIQ, height or weight, anything I can take it, just to see whether their mean values are identical or not. So here I'm just calling import numpy shape. I'm saying 40 rows and 8 columns are there and the names are provided there for the particular column. Okay, so let's see the t-test here, actually how the t-test is working. So let me come here. Okay, just wait here. Like there are a lot of things added. Okay, just you can see here. I'm just calling SciPy. From SciPy, I'm just calling stats. From SciPy, import stats, because inside the SciPy.stats, I'm having value of t-test. These functions are there. So there are, when we work on the t-test, so there are different types of t-test. So basically, t-test is most commonly applied when the test statistics would follow a normal distribution. So here we do call this t-test as the parametrical statistical significance test also. So there are certain type of t-test here, just like the one sample t-test or two sample t-test as well. So basically, t-tests are being used whenever we want to work with a statistical test, which is widely used to compare the mean of two groups or samples. So here, just see, suppose, okay, let's understand now. Suppose here, there is one of the column PIQ. PIQ is one of the column you had seen above. I want to understand that this PIQ column has mean value identical to 106. I'm saying PIQ column has mean value identical. Identical means nearby to, similar or nearby to 106. That is not equal, that is nearby, somewhere similar to 106. So data is one of the data frame I had created. So I want to understand that this particular column, when it's all the values are calculated and find out the mean, so that would be nearby 106, identical to it. So for that, there is one of the test here, t-test one sample. T-test one sample. So here, stats dot t-test one sample, and here PIQ column I'm taking, and I'm saying this column mean is identical to 106. I send this, I just return, I executed this t-test one sample, and once it does all the work as per the formula, so here we need to check as the response. In response, I need to check this p-value. So I will be checking this p-value only, this part only. There are so many parts coming, I need to check p-value. In p-value here, now, I need to check one thing. What is the p-value coming here? See carefully here. 0.16. Let me take here. P-value 0.16. This value is coming. I told you that p-value, when this is greater than 0.05, so null hypothesis is accepted. So right now, p-value I'm getting, that one is a 0.16. So that one is greater than 0.05. So in this case, I will say H0, null hypothesis is accepted. I will say null hypothesis is accepted and alternative is rejected. So what does it mean? It means when null hypothesis is accepted, so I had created two statements. Okay, so it means the mean value of PIQ is identical to 106. This is true. Because in null hypothesis, I had wrote the two, the provided two mean values of a given sample are identical. This statement I had given in null hypothesis. So I'm saying here, P value is greater than 0.05. This P value is greater than 0.05. Hence, null hypothesis is accepted, alternative hypothesis is rejected, which says it is true that the mean value of the provided data is identical to this number. So here we need to check it. This is first case. The same case I want to do with another column. Above you have seen there is one of the column FSIQ. So here I'm just using stats t-test one sample data and FSIQ. I'm saying this FSIQ is nearby to 108. So once I evaluated it here, it is saying p value greater than 0.16. So 0.16 is greater than 0.05. So here I'll say null hypothesis is accepted and alternative hypothesis is rejected. It means FSIQ mean value is somewhere identical to 108. This is a case here. No one is going to create the case. The hypothesis testing cases are default. They are default. They are default here. So here it is mentioned already, student t-test is a statistical test which is widely used to compare the mean of two groups of sample. Okay, it is therefore to evaluate whether the means of two sets of data are statistically significant or different from each other here. So their hypotheses are created as default here. 108 is any mean value. This is not a data point. This one is any mean value, identical mean value, nearby mean value. We are putting it here. Now, when I checked out the mean, see here, I had written a value here, PIQ is PIQ mean value is identical to 106 or FSIQ mean value is identical to 108 here. And here, when I'm checking it out, actually, here PIQ value is nearby 111 and FSIQ mean value is 113. So it means here that actual value is 111 and here the actual value is 113, which is similar, identical to nearby to 106, or this is identical to 108. It is not exact, but identical. So hence, P value is greater than 0.05, as it is saying it is 0.16. So the null hypothesis is accepted here. Now there's another. See here. Suppose I am taking the two. I'm taking FSIQ column as well as I'm going to take the PIQ column here. I'm taking both. Now I want to find out what is the mean value. It means I'm saying that the mean value of FSIQ is identical to PIQ. That I want to prove. So by default, H0 is two mean values are identical. And HA is two mean values are not identical. So here, FSIQ, what is the mean? 113 and PIQ mean is 111. So this stats D test independent is another library which is going to calculate the mean value of FSIQ, PIQ mean value and find out whether they are identical. So here 113 is the mean value of FSIQ, 111 is the mean value of PIQ. Now let me check it out the P value. P value is coming as a 0.64. 0.64. So it means 0.64 is a P value greater than 0.05. So in this case, P value is greater than 0.05. So it means null hypothesis is accepted and alternative hypothesis is rejected. Okay. Okay. So null hypothesis is accepted. So here I'm saying, because P value is 0.64, so here I will say null hypothesis is accepted. H0 is approved. It will say the two mean values are identical. Okay. Just okay. So in this way, we need to understand or interpret the results. You need to just to understand the concept. There's no need to build up. Just basic understanding you need to do. Okay. Now, this is p-value. Now, let's understand here that how we do the hypothesis test. So here, we need to define the study question. We need to find out null and alternative hypothesis, and then we need to choose a suitable test. Okay, so we need to calculate the test statistics. We need to calculate a p-value, and with the help of p-value, we need to make the decisions and interpret conclusions as well. Now let's understand the power of test. This one is the power of test, basically. Power of test, we call it. We can call it technically as a confusion matrix also. So let's understand what is this actually, how we can understand it. Because all this relate with the machine learning now. So here now, suppose here I'm saying, yeah, you can try to get any mean values as well. Now, let's say, suppose here I'm saying that I had collected 5,000 data. 5,000 data. So basically, 5,000 forms. I need to put that one into some software. So the point is here, when I'm getting this 5,000, so whether I received entire data correctly. So this is the question now. So basically, how can I understand it? So basically now, see, the confusion matrix of the power of test is built in this way. See. All the data just coming here in these two, they are right data. So in 5,000, see, suppose I'm saying in first time that null hypothesis is true. So let's assume I'm making assumption that I had received 5,000 forms. So when I evaluated all the forms, so I will say 4,000 rows, 4,000 people forms I get whose statements are favoring null hypothesis. So whatever statements inside the null hypothesis that is being favored, and 1,000 people statements are favoring alternative hypothesis. So null hypothesis are greater statements into the number. So it means null hypothesis is accepted. This is one case. The second, I have to check it out here, alternative hypothesis. This one. Here, this one is there. Error, error. Actually, now these two blocks confirm certain error. So currently, because 5,000 rows are either here and or here, but none of the rows are left. So here I will say there is a zero error, zero error. So what does it mean? It means whenever we are looking this power of test, so inside this power of test, the statements which I am getting here, the statements which I am getting, students, here now, in these two boxes, they are the correct statements which are coming into the diagonal. And the statements which I'm getting here, they are the error cases. Error cases. Okay, so right now, zero error, zero error. So here I'm saying zero error, because all the 5,000 rows are calculated here only. So 4,000 here and 1,000 here. Okay. Now let's take a second case. Second case here I'm taking. All the PowerPoint are present inside the notes and resources repository in the end section. Once you go to the notes and resources repository, you just move to the last section. There you will be finding certain links. Into that you can find out the PPTs. Now let's see what happens to the error. You find out the situation where suppose you think I'm getting, instead of 4,000, 3,500 data correctly filled from the form, and 500 forms, or this is too high figure. I want to change it a little bit. This is too high figure. Let's say 3,800 rows or forms are filled correctly, and 200 forms, I had find it out, they are not filled correctly. 200 forms are not filled correctly. So it means some of the people has left out certain questionnaires. Okay. Because I had given the forms in two format, Google Forms or paper format. So some of the forms are unanswered, or in paper format also, some of the people have just made certain cuts. And cuttings are there. So we are not getting the clear answers. So it means 200 forms I had received with mistakes, or I cannot take those forms correctly. 100% they are not filled. I say like 50% are filled, 50% are remain blank, or certain cuttings are there. So I cannot take them as a complete one form. So it means 200 forms are in this way also. I'd find it out. Second case here. If 1,000 are written here, so I can say 900 forms are filled correctly and 100 forms are not filled correctly. Okay, so that is there. So error here and error here. Okay. So these 300 forms are incorrectly filled. They are not the right way forms. So these forms are not correctly filled here, so errors are there. So that can also happen during the power of test. So students, here na, what should be evaluated, what should be checked? Here we can check out this diagonal. The values or the number of forms which is present inside this diagonal. So I will say for H0, correctly filled forms are 3,800, and for HA, alternative 900 forms are filled correctly. Here, 200 forms here filled incorrectly and 100 are not filled correctly. Got the point? This is a case of power of test. So remember that whenever we are checking out the power of test, so the values which are lying here inside this diagonals, they are the right values. And any values which are incorrectly filled, they will come here into the error zone. And that can happen into the power of test. That can also be called as a confusion matrix. Power of test or confusion matrix we can call. So we'll be using it in future. So this one is just an introduction to the power of test or matrix. So here, this one is the same here. We call it a power of test. And when we check out these value here, type 1 error and type 2 error, this one here and this one. Okay. Okay. Now let's see hypothesis test. Like here, right now, I had just told the T test. We call it a student test or payability test. Now let's go ahead with a correlation test here. Correlation test. Let's understand what is a correlation test here. I'll be just doing step by step here. This parametrical significant test are the T test. These are all things which I'm discussing. Whenever I want to have a measure of relationship, so there I can go ahead with regression test. So basically now you think it, suppose, let's say I'm having two variables. Okay. So let me take two variables randomly, height and weight I'm having. Two variables and I'm having a lot of values for it. Now suppose here, I want to understand whether height and weights are having certain relationships. They are having certain covariance to each other, or they are having certain correlation to each other. So if I start plotting these height and weight value with the help of regression or certain scatter plot also, I can do that. So if I'm getting the values in this way, so what does it mean? I will say that there is a positive relationship between the height and weight with increase in height. So it is correspondingly increase in weight also. It means with increase in height is increasing the weight also. Increase in height will increase the weight as well. If I'm getting, suppose you see, I'm having a data where suppose my values are house price, means house price and crime rate in a particular location. If I started making a scatter plot, so, and if I'm getting the scatter plot in this way, so I will say negative relationship, which means in area where crime rates are increased, so their house prices are automatically decreased. Okay. So this is there, right? So here means you should know that whenever we need to understand whether the two data or two variables are correlated to each other or not, so we can do certain regression test. So there, this we call it as the measure of relationship. So how we can do that? Basically, measure of relationship, that one is a covariance. If you want to find out the measure of relationship, that one is a covariance. Covariance is a measure of relationship between the variability of two variables that shows it measures the degree of change in the variables when one variable changes. Okay. Now see, what are the formulas of covariance? This was the formulas of covariance. Sum of the dot product, and dot products have the difference between x minus mean of first variable and y minus mean of second variable divided by total population, total number of rows. This formula will be finding it out the covariance between two variables. So this is known as a covariance between two variables. We can find it out. And this one is when we find out the covariance between the two variables, so then we can find out the coefficient correlation R also. That one is like if I'm getting my coefficient correlation data points in positive way, so I will be saying that the relationship is stronger between the two variables. So there is a value of calculated values of coefficient correlation R. If the values are between, means all the values are lying between 1 or -1. So the point is, any value which we are moving towards this side, towards positive one side, it means the relations are very strong between the two variables. And if the values are moving towards the minus side, this side, so the relations are negatively related with each other. And if the values are coming this side, so we can say the relations are zero. The relations are neutral with each other. Now correlations gives a better understanding of covariance. It is normalized covariance. Correlation tells us how correlated the variables are to each other. If I want to find out coefficient correlation R, which is P, so we need to find out the covariance of two variables divided by standard deviations of two variables, X and Y. So these formulas are working. So here, let's say, suppose, here it is just given that if we are having the correlation, coefficient correlation R value between 0.5 to 0.9 side, means one side, so it means strong relation, or if I'm getting the values with 0.9 or 1, so that they are very strong correlations with each other. And if we are getting the value between these, so they are weak correlations with each other. Now here, suppose I want to understand how to find out the calculation. So basically, suppose I'm having two variables here, height and weight. I want to find out here height and weight. So first of all, to understand or to find out this formula, if I want to calculate R, so covariance of X and Y divided by standard deviation of X and Y. To find out this covariance here, so first of all, we need to calculate the covariance of X and Y here. So to calculate it, we need to make sum of X minus mean of X multiply by Y minus mean of Y. One is to calculate it divided by N. So that we can calculate it with the help of X, covariance of X and Y. So to calculate this and this value, we need to calculate X minus mean, Y minus mean. This we need to do the calculation. So X minus mean, Y minus mean, we need to calculate on the basis of this. So suppose this is X, this is Y. So height minus mean and weight minus mean. Then we need to make the dot product, just like here one is making the dot product here. So here one need to make the multiplication of it just to come this side to calculate this formula. And then we need to make x minus x bar also and y minus y bar so that it could be settled into this one. Okay, so this entire settlement one needs to do it here. And then if one needs to calculate it here, entire R on the basis of this sum and weight here. So here sum of height is 25.7, sum of weight is 250, and this one is the mean of height and mean of weight. This one is sum of x minus x bar, y minus y bar is 26.74. And this one you can see it x minus x bar, sum of x minus x bar, and sum of y minus y bar. The values are related here. We can settle down all these values inside the correlation into the formula. So this one is basically covariance divided by standard deviations. Covariance of x by y divided by standard deviation of x and standard deviation of y. These values are settled here, and when the values are calculated here, so one is getting the R value here as 0.889. What is this 0.889? 0.889 is coefficient correlation R. What does it mean actually? So if I say R value is 0.889, so it means the coefficient correlation R values, if that is towards here, suppose R is saying 0.889, so it means it is lying here, so it shows positive relationship, very strong positive relationship between height and weight. This shows strong positive correlation between height and weight. So here it is saying the data provided into the height and the data provided into the weight, that is having very strong correlations between height and weight. Okay. Okay. So that is there. But the point is, student, here that for this, we are having, suppose here I say, actually there are certain libraries we do have. We are not calculating so much actually. We do have a libraries for this. So for libraries here, like here in scipy.stats, to calculate the coefficient, there are two libraries such as from scipy.stats, import Pearson R or Spearman R. These are basically library if we want to use it from scipy.stat. But there is one more very easy library just to calculate the coefficient correlation R if I want to calculate this entire way. This one, if I want to calculate this one. Okay, how I can do that? So very easy library is there inside pandas. Entire calculation will be done. This entire formula calculation will be done. So inside pandas, there is one of the very effective library that is core. So if I use core function, so this core function, pandas.core function will give me the coefficient correlation R value. So regression test automatically, this one is doing that. So how to use that effectively, basically? Suppose I'm having a data. I want to find out coefficient correlation R. So how? Suppose this one is a data. Let me take out the data. And I want to find out coefficient correlation R. For that, I need all the numerical values. So this data I will be taking. Suppose I'm taking, suppose I need entire data, or up to here I need a data. So how can I take it out? Suppose this one is a DF now. So I will just write df.ilog. And how can I select it? Give me all the rows from 0 to -1. If I'm writing it here now, So from maths to history, I can get the data. This is one. Or what I can do, df.ilog function, and here I can just write, give me all the rows starting from 0, 1, 2, 3. 3. Starting from 3 to end. If I'm leaving it end, so it will be taking up to end, or 3 to minus 1. Okay, no. 3 to end. 3 if I'm giving it, so entire data will be taken. So any of the way I can just choose it, just to take out the data. So anyway I can take it. So okay. 3 to 10 here I'm giving it. 3 to minus 1 also I'm giving it. Okay. Suppose here, just wait here. Okay. Suppose here I'm just taking this data. Let's say suppose I'm taking this data up to 3 to minus 1. So here it is taking all the data, taking df.ilog, give me all the rows 3 to minus 1 here. So here it is taking all the data up to minus 1. 3 to minus 1. Or 3 to 10 also if I'm giving. So here also I'm getting this data. So any of the way I can just select the data, I can cut the data. And what I can do here, if I wait 3 to minus 1, I have taken the entire data. So math to history, all the rows I'm having, numerical data here I'm having. And here, if I want to find out the correlation, so I will just write here df.core. df1 is the name I had provided to hold the data. This one, df1 I had written, df1.ilog, df.ilog, I'm taking all the data here. Okay, math to history. And now I want to find out correlation coefficient R. So I will simply write here pandas library df1.core, and I can hold the result inside the DFC. So you can see all these correlation which are calculated, they are on the basis of covariance of X and Y divided by standard deviation of X and standard deviation of Y. So here this R is calculated just by this formula. Entire thing. So I'm not going to do anything. Automatically I'm having a library. And now when I'm passing these results into the heat map, because here all the numerical values I'm getting, these are calculated R. So these are basically coefficient correlation R. Coefficient correlation R I am having. So here now what I can do, I can store this DFC. What is DFC? DFC is basically, this one is R calculated value. So I can take this DFC and provide it inside the heat map to see the value. So basically here now, these all values are coming into the numerical data. I can see this value inside in this way with heat map. So I'm getting this data in some colors. So wherever I'm getting lighter shade, this shade, light shade. So here the positive correlations are there. And if I'm getting negative, so here negative correlations are there. Okay, positive correlations or the negative correlations are there. Okay. So you can take a heat map, or what you can do, you can take, you can see here, students, if I'm passing these values, so I cannot see these numerical values here. Only colors are coming here. But if I want to see these values, you can see here, you can see certain points are coming here, and these are calculated coefficient R. Can you see some values are coming here? Numerical values are coming here. These are all calculated value R, basically coefficient correlation R, which you are getting from here. These values which are getting, these are here. So DFC, CMAP is equal to blues, annotation is equal to true. Okay. Okay, TFC, CMAP is equal to blues. CMAP is color map, so color shades are there. Annotation. So this is annotation. Annotation is equal to true. So whenever you are giving annotation is equal to true, so these calculated value will start coming here. So here in colors, all the colors which are coming to this darker side, they're in positive correlation towards 1. And if they are coming towards downer side, they are negative in correlations to each other. So in this way, we need to understand, we need to interpret the values coming. Okay, whether those variables are having higher correlation. So upper side towards one side, we need to check it out. And if they are coming towards downside, negative side, so it means negative correlations with each other. In this way, we need to understand the values. Okay, and color map is here. Whatever color I want to put, I can put that. Default color is this one. And this one color, CMAP is equal to pools here. Okay, so this is, we are just reading the inferential steps. Thank you, Dan. Thank you very much. Thank you. You can find out the PPTs inside notes and resources repository. You can just scroll down notes and resources repository to the end section. There are certain links you will be getting. There the PPTs are loaded. You can just check it out. Thank you very much. Thank you very much. Thank you.